we need to find the value of the following expressions. So let's begin with number 1. So here we will begin with the exponent or the power part. We have log of m with a base of 10. This is added to 2 times log of n with a base of 10 plus 3 times log of p with a base of 10. Now we want to add this 3 logarithm, but we cannot do that because if we look at the second term and the third term, here we have a coefficient of 2 and 3. In order to add the 3 logarithms, the coefficient should be 1. However, this is not a big issue. We can get rid of the coefficient 2 and 3 by using a property of logarithm. So if we have a times log of p, that will be equals to log of p raised to the power of a. We can rewrite this to get log of m with a base of 10. This is fine. Now, so the second term will then become log of n squared with a base of 10 plus log of p cubed with a base of 10. Now, all the 3 logarithms has the same base of 10. So now we can add them. We will use the property if we have log of a added to log of b. So that will be equals to log of a times b. Fine. So this will give us log of m times n squared p cubed with a base of 10. Now coming to our actual problem. So here we have 10 raised to the power of, this is the expression which I've already reduced it to, log of m n squared p cubed with a base of 10. Now we will use a property of logarithm which says that if we have a raised to the power of log of b with a base of a, here the base of the exponent is a and the base of the logarithm is also a. When they are exactly equal, then the entire expression becomes equals to b. So here we have our base of the exponent is 10 and the base of the logarithm is 10. So that means the expression will reduce to m times n squared p cubed. So this is going to be the value of the given expression, m n squared p cubed. Okay. Using similar logic, we can also compute the value of part 2. So let's do that. So here we'll begin with the exponent part. So here we have log of 2 with a base of 10 plus log of 3 with a base of 10, and this goes all the way up to log of n with a base of 10. So each of the logarithmic term has the coefficient of 1, so we do not have to apply any other property here. All we have to do is straight away add them. So adding them means simply we'll multiply 2 with 3, 3 with 4, and this multiplication will go all the way up to n. And we can say, we can also put in 1 here. It won't affect the multiplication. However, when we have 1 multiplied to 2 multiplied to 3 all the way up to n, then this is actually the factorial n. That means n factorial is given by 1 multiplied to 2, 2 multiplied to 3, 4 all the way up to n. So that means we can replace this with a 1, 2, 3, 4, the product with n factorial with a base of 10. So that means our expression 10 raised to the power of log of 2 all the way up to log of n. So this is 10 raised to the power of log of n factorial with a base of 10. So we have the base of the exponent and the base of the logarithm exactly equal. So this will be equals to n factorial. So that means our value of this given logarithm is going to be equals to n factorial.